In the beginning, our universe was very hot and dense. As the universe cooled down, the electrons interacted with the nuclei, forming the first atoms. A few 100 million years later, the first stars and eventually galaxies appeared. But how did they form? This thing will help us understand. A $10 billion time machine which has been in development for over 20 years. Imagine that you are 65 million light years away from Earth, somewhere in the Virgo cluster, and you have a very powerful telescope which you can use to study the Earth. Taking a look through the telescope, you would be able to see what dinosaurs looked like on our planet. Of course, we will face many obstacles along the way, but we are talking about an incredibly powerful telescope, right? The James Webb Space Telescope is exactly that. It is 100 times more powerful than the Hubble telescope. Just look at the comparison of the sizes of their primary mirrors. And yet, James Webb's mirror is 113 kilograms, 249 pounds, lighter. The telescope works in the infrared spectrum. The infrared radiation can penetrate the dust cloud and allow us to see the stars forming within. Additionally, Einstein's theory of relativity states that the space between objects in our universe expands, and so does light. As the light from the first stars and galaxies travels in our direction, its waves lengthen and the light becomes infrared, also known as redshift. Every time you look up at the night sky, just know that there are many stars and galaxies, the light of which stretched and became invisible or too faint for you to see. So here's a question. How is the James Webb Space Telescope supposed to detect that light? It will be assisted by a huge mirror which will increase the amount of collected light. The more light, the more detailed the image. The mirror is made with 18 hexagonal segments, each one 1.32 meters, 4.3 feet in diameter. This shape will enable the crew to fold the mirror on Earth and unfold it in space. Then, the focus of the mirror will be calibrated by shifting the various segments with an accuracy of 1 to 10,000, 1/10,000th of the thickness of a human hair. The light is collected onto the secondary mirror. Then it is reflected and sent to the scientific tools. After it is filtered, it is then focused on the hypersensitive infrared detectors, at which point the photons are converted into electrical voltage. The actual telescope is equipped with 4 tools. NIRCam is the telescope's primary imager in the near-infrared range. 10 sensitive detectors allow it to detect the light of the first stars and galaxies. In addition, NIRCam is equipped with chronographs. And what are they? Imagine that you're blocking the sun with your hand. By blocking the bright light, you can see the road ahead of you. A coronagraph follows a similar principle. This function will allow researchers to see more faintly lit stars, galaxies, and even take photos of exoplanets. But NIRCam cannot show us everything we need to know about the physical properties of a planet. Is there water? Air? Impossible to say. Therefore, another tool called NIRSpec will be working with the same range. By studying the spectrum of light emitted by an object, we can tell its mass, temperature, and chemical composition. The atoms and molecules of an object leave their mark on the spectrum in the form of black lines. But to analyze the faintest light, the telescope has to stare at the object for over 100 hours, which is ages. But surely the scientists did not spend 10 years working in vain. To avoid wasting the telescope resources on a single object, the NIRSpec is equipped with a superpower to provide spectroscopies of hundreds of objects at once, which was achieved by developing a new technology called micro-shutter system. This system is made of 250,000 shutters that open and close. If you ever observed the night sky in a town or city and compared it to what you can see at night in the countryside, you could probably tell the difference. It happens due to the high volume of light in the city. Therefore, the micro-shutter system will block the irrelevant light, allowing us to see the most faintly lit objects. The light is then dispersed into the spectrum and sent to the detectors. How much light is there in outer space? A huge amount, and in order to capture only the relevant light, the telescope has to be constantly directed at different targets. This will be possible with the help of the Fine Guidance Sensor, FGS. Additionally, scientists from the Canadian Space Agency developed the Near-Infrared Imager and Stiltless Spectrograph, which also takes pictures and captures spectroscopies in near-infrared light. But how do we deal with thick dust clouds that obstruct the view? Near-infrared light might not be able to penetrate them. And that's where the last tool comes in. MIRI is also equipped with a camera and a spectrograph, but it works in a different range of infrared light, one with longer waves, which can penetrate the thick dust clouds. Its sensitive detectors will allow us to observe the red-shifted light of distant galaxies, newly forming stars, and comets. The issue with MIRI is that unless this tool is cooled to 6.7 Kelvin or -266.5 Celsius, it starts capturing its own heat. So scientists developed an additional cooling system called cryocooler. In essence, it's a sophisticated refrigerator in which helium will travel along pipes, cooling MIRI to the right temperature as a result. But now we have a different problem: the Sun, the Moon, and Earth radiating heat. And as a solution for this problem, the engineers developed an incredible passive cooling system for the telescope, the Sun Shield. The size of this shield is 21 meters long and 14 meters across. The shield is made up of 5 layers, with space in between each layer of material so they can cool efficiently. Each layer is made from a special film that can withstand very high temperatures. This material is called kapton. In addition, each layer is coated in aluminum, and the first 2 have an additional coat of doped silicone in order to be able to withstand even higher temperatures. For the Sun Shield to be able to hide the telescope from the Sun, the Moon, and Earth simultaneously, the JWST has to be 1.5 million kilometers away from Earth. As a reference, the Hubble Space Telescope was only 547 kilometers. The James Webb Space Telescope will travel to a special location known as Lagrange Point 2. It is one of the 5 places in the solar system where gravitational forces allow the objects to remain in a fixed position relative to Earth. Remember how we talked about a folding mirror? Similarly, the Sun Shield and many other components will be foldable. This way, the scientists can fold the telescope and pack it into the rocket Ariane 5, which is the most reliable rocket capable of delivering the telescope into space. And now, let's talk about the most exciting thing: the possibilities of the James Webb Space Telescope. We already mentioned its ability to capture faint infrared light emitted by the first stars and galaxies. So what's next? Well, for example, you could spot the heat signature of a bumblebee at a distance of the Moon with the JWST. But why should you care about a bumblebee? Did you know that Saturn is not the only planet with rings? Uranus, Neptune, and Jupiter have them too. It's just that in the visible spectrum, their rings are dark and indistinct. Using the transit method in the infrared range, the telescope will be able to help us understand how the rings around these 4 planets formed. Well, what about a detailed analysis of an exoplanet's atmosphere? The researchers are interested in the planets located in the habitable zone, which means they might contain water. By using the telescope, we can learn the chemical composition of those planets' atmospheres. Scientist Michio Kaku thinks that the chances of encountering an alien civilization are quite strong. The telescope will be able to tell us more about the birth of galaxies, stars, and planets. It may completely change science as we know it. The universe keeps many secrets, but the James Webb Space Telescope should help us uncover these mysteries. And in the meantime, we will continue to delight you with new content.